Okay, so far in chapter 6, we have looked at the sine graph or sine curve and the cos of theta curve, and looked at questions pertaining to each one, how to draw them. So now we're going to relate kind of what we did in chapter 1 with what we've learned so far in chapter 6. So we're going to look at the sine. You can write that down. We're going to look at graphing, y equals sine of theta and y equals the cos of theta curve, and then transforming them. So recall, if I had the equation y equals a, so a is a vertical stretch or compression, and if it was negative, it would be a flip or reflection over the x-axis. That would be from grade 10, right? And then f, a function. K is the only new part of grade 11, which is my horizontal stretch or compression. And if k was negative, inside the bracket, but in front of the x, then I would be flipping it, reflecting it over the y-axis. The d value is a horizontal shift left and right. So if it's negative in the bracket, I'm shifting right. If it's a positive in the bracket, I'm shifting left. And the c at the end is a vertical shift up and down. So positive is up and negative is down. So we can apply these same transformations to the y equals sine of theta and y equals cos of theta graph, except that the transformations have special names. So now let's take a look at what it would look like in terms of relating it to the graph. I just need some room to write around here. I'll write some above and some below. Okay, so now if we have y equals a is now the amplitude. So a is the amplitude. I'm just going to put amp for short, right? And so the amplitude is always a positive value. I'm just going to put this for short, positive value. Because your amplitude is your distance, right, between the equation of the axis and the peak, the highest point, or the equation of the axis and the trough, the lowest point. So again, kind of like that question we did before where you walk out of your house and you turn left or right, how many steps am I away from home? The absolute value function, it's always positive. So the amplitude is always positive as well. The K value is the number of cycles that I have between 0 and 360. So it helps us find the period. So I'm going to break that above to have room. So the K value helps us to find the period, right? The cycle. Where does it start and stop? And then I can see it continuing on, starting and stopping over and over again. So it helps us to find the period. And so what I do is I have my 360 degrees and I divide that by K. And I'll still write up above here. So K equals the number of cycles between, for short, between 0 and 360 degrees, 0 and 360 degrees. So my D value is my horizontal shift, but in terms of the sine curve and cos curve, we're just going to call it a phase shift. And so we're moving it left or right. And for my C value, it's again just a vertical shift up or down. So we're going to call it a vertical. We're just going to use the word displacement because it's moving the graph, right? Up or down. And y equals C is the equation of the axis. Y equals C. So whatever the number is at the very end is the equation of the axis. The equation of the horizontal line that basically splits the curve right in half, right? So let's do an example here. Just change my color. So find the amplitude, the period, the phase shift, and the vertical displacement. So it's just, again, the amplitude would be my A value, right? The period would be my K value, the phase shift would be my D value, and the vertical displacement would be my C value. So I'm going to get that out of here. So now you see I have a function in terms of theta, and it's the sine curve. So it equals -2 sine inside the bracket 1/2, and then theta minus 45 degrees, and then everything subtracted by 9. So what is the amplitude? So again, the amplitude, or A, is going to be 2 because it's always positive, right? So that just means that my amplitude, my distance between the equation of the axis and the peak or the trough, is going to be 2 times as high. So my graph again is going to look basically vertically stretched out by 2. And then I have the 1/2, which is the K value, which is the period. So again, for the period, I want to do 360 degrees divided by K, right? So then I'd want to do 360 degrees divided by, if K is 1/2, that would be like 360 degrees. Remember, you don't divide, you flip and multiply. So if I change that dividing to multiply, and I flipped 1/2 to 2/1, that'd be the same thing as 360 times 2. So that would be 720 degrees. 360 twice would be 720 degrees. So that means my period is actually going twice as stretched out, right? Just like the half in chapter 3 would have been a horizontal stretch outward by 2, it's getting 2 times as stretched out. So if my regular cycle goes from 0 to 360, now it's taking all the way to 720 degrees to do one full cycle, one period. So the phase shift here, we'll call it PS, the phase shift is 45 degrees. And because it's negative, we're going to move right. So every dot is going to be shifted 45 degrees to the right. And the vertical displacement is just shifting down by 9. So 9 units down. But don't forget that that's also telling me what the equation of the axis is. So the equation of the axis then would be y equals -9 in this case. And just to point out here, the x-axis will be in degrees, right? So you're 45 degrees right, 720 degrees for the cycle. So the x-axis is in degrees, but your y-axis is not. But your y-axis, it's just regular numbers up and down. Like here, the equation y equals -9, you would go to the y-axis, find -9. So your y-axis is not in degrees. The x-axis is in degrees, the y-axis is not, I'm just going to say, meaning that it's just the way it was before. Okay, let's try another example here just to get some more practice with the same thing. Find the amplitude, period, phase shift, and vertical displacement. And in this case, let me just move this up. Okay, I'm going to leave some room up above because I don't have a lot of room here. Okay, so you can see here that my amplitude is never going to be negative. So my amplitude is going to be 3, right? Now I'm looking at the Cos curve, but I have a 4 inside the bracket, but in front of where the x used to be, or in front of theta now. So that's my period. So my period again is just 360 divided by whatever that number is. So 360 divided by 4, so 90 degrees. So what used to take 360 degrees to go through one whole cycle is now only taking 90 degrees to go through one whole cycle. So same thing as before, it's a horizontal compression and the graph is going to look squished, kind of like it's being divided by 4. So again, that's what we did here, was divide by 4. So now I could fit 4 cycles in the span that I could have just fit one original cycle that took 360 degrees, right? So my phase shift here, right, it's negative. So I'm going to move positive, but I'm only moving 135 degrees to the right. And my vertical displacement, sorry, let me just finish this question first, is moving up 1, right? So my vertical displacement is moving 1 unit up, is equal to 1 unit up. And then don't forget that your x-axis is in degrees, but your y-axis is not. So now what we're going to do next is, again, looking at the equation. We have our amplitude, we have our period, we have our phase shift, and we have our vertical displacement. And it tells us on the graph, our x values are going from negative 360 to 360. So I'll just have to clear this and move it up. So I want you guys to start thinking about, what these numbers mean and what shifts are going to be happening in the graph. And again, first I can see its sine. So my first step would be to draw my x and y axis and draw my regular y equals sine theta curve. Oh, I'm just looking, sorry. Why was this 135 degrees? I didn't mention that here. So don't forget, the same as in chapter 3, when I'm rewriting my equation here, -3 cos of bracket, remember that there should be another bracket inside. So there should be a 4 and then another bracket. So if this number here is not factored out of these two terms, I need to factor them out, which we didn't see a lot, maybe in 1 or 2 homework questions, but it wasn't on your test, I don't think. So if I factor out the 4, then I'm left with theta. And then if I take negative 540, right, divided by 4, then I'm left with 135. So then that's where I get minus 135 degrees. This is the way it's supposed to look, right? And then you have your double bracket plus 1. So again, this number, right, should be in front of theta, or what used to be in front of x, and there should be a bracket between them. So just a reminder about that. If there isn't a bracket between them, you need to factor it out. And then this is my period. So that didn't change this at all. I still divided by 4, but it changed the phase shift. So I'm moving 135 degrees to the right. Okay, so now let's move on to y equals 3 sine theta plus 45 minus 1 between 360 degrees and negative and positive. So let me clear this and move this up. Okay, so first is basically my y-axis then could go right in the middle, right? Because I have the same amount of x values on the left as is on the right. So if I just count this through here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then I'm just going to get a thicker line here to draw from my y-axis. And then same thing, my x-axis, I want to be roughly halfway as well. Technically, I need a little bit more room on the positive side. So I'm assuming, yeah, this looks more rectangular than square. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 1, 2, 3, 4, 5, 6, 7. I hope will be enough. Okay. So we call this now, we would say that our x-axis now is theta, right? Because instead of where x would be, we now have theta. And we can still call this our y-axis. So first I have to label my degrees, right? Because my x-axis, my theta now is in degrees. So I have to get from positive 360 to negative 360. So I'm going to go by 45 degrees here, and I'll show you why in a chart in a second. So if I have 45 degrees and then 90, and then I have 135 and then 180, right? And then 180 plus 45, so 225, and then 270. And then 2 away from that would be 360 positive. And I do the same thing on this side, 45 and then negative 90. And then 2 away would be negative 180. And then 2 away would be negative 270. And then the last one here would be negative 360. So we just fit it. So perfect that I was able to put my y-axis. So that's why you kind of have to count it through and see at first, right? So if I have my theta here and I have my y equals sine of theta, in that 6.1, when we did the degrees and we made the chart, let's say theta was 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So these 1, 2, 3, 4, 5 values are going to be what I use to graph sine of theta and cos of theta all the time. So again, if you just plug that into your calculator, what is sine of 0? 0. What is sine of 90 degrees? You'll get 1. What is sine of 180? 0. Sine of 270, negative 1, and sine of 360, you would get back to 0. And I'm going to use that to draw this. So I'm at 0, 0 here. Let's use a different color. So let's say that this is orange. So sine of 0 is 0, and then at 90 degrees, I'm up to pause. Oh, I have to label, sorry, my y-axis, I didn't label. So let's go back to purple. And let's do every other one as 1 unit. So kind of like going up by 0.5, because I have room. So skip 1, this is 1, skip 1, 2, skip 1, 3, skip 1, 4, and I still have room for 1 more there, and then that would be negative 0.5 and negative 1, skip 1, negative 2, skip 1, negative 3, and then I should have 1 more line down there. All right, so let's get back to my points here. So at 90 degrees, I'm at positive 1. At 180 degrees, I'm back at 0. At 270 degrees, I'm at negative 1. And then at 360, I'm back at 0. And then that would be the same for if my negative values, right? At negative 90, I would be at negative 1. At negative 180, I would be at 0. At negative 270, I'd be at positive 1. And at negative 360, I would be at 0. And as best as I can, again, it's easier on paper, I want to draw a smooth curve, sine curve here. Best we can. Not too bad so far. Okay, and it would continue on if my degrees went onward. So if I wanted to, I could always put like an arrow on the ends there. For my domain and range, right? For my domain, it's going to continue on to the left and it's going to continue on to the right. So now let's start talking about my shifts. I don't have anything written down here as to what my shifts are doing, right? So this would be, let's say, step 1 is to draw the sine curve, right? Which is the parent function, if you will, from chapter 3. Draw the parent function using these 5 key points, and then just continue that on the left-hand side for the negative part of theta. For step 2, let's do the vertical stretch, which is the amplitude. So let's change the color to green. So for step 2, let's do the vertical stretch, or again, just like reading an equation, like reading a book from left to right, the first number I see is the 3. And the 3 is now equaling what our amplitude is. which means it's going to be 3 times as stretched, right? So if it's 3 times as stretched, I'm just going to do literally that. I'm just going to take, so what is 0 times 3? 0 times 3 is still 0, right? But what is 1 times 3 is now going to be way up here. 0 times 3 is 0. Negative 1 times 3 is now way down here at negative 3. And 300 and 0 on theta here, sorry, times 3 is still 0. So just to kind of say, I still have to put green there. Wherever it's 0, it's going to stay and remain 0. But the values of 1 and negative 1 are going to go up to 3 and negative 3. And same on this side. Negative 1 times 3 is going to be negative 3, 0, positive 3. Get them in the right spot there. And 0. And this one's going to be a little bit harder to graph because it's more stretched out, right? Do our best here to join this together to come back down to 0. Get back down here to negative 3, but come back up here to the origin, 0, 0. Back up here at 3 again at 180 degrees. I'm going to be at theta is 0. Back down to negative 3. And back up to theta being 0 degrees. My left side started out pretty good. I got a little bit, but overall I'm pretty good. And again, you can continue those on with an arrow if you want. So now we've done this stretch. Now we don't have anything to start out the first graph. Let's do red. We don't have anything in here, right? We don't have a horizontal stretch or compression, or the period doesn't change. So in terms of it getting stretched out horizontally or compressed horizontally, for right now, we're not going to be looking at that. So I'm just going to erase this here so I can still use my red. So we are looking at a phase shift then, step 3. A phase shift and a vertical displacement. We can do, again, I usually do those 2 shifts together. You can do them separate if you want, as long as your final graph looks like the graph I have in red. Okay, if you want to do your horizontal shifting first. So we're going to do a phase shift and a vertical displacement of 45 degrees left, right? And 1 unit down. And then just double check that. 45 degrees, it was positive, so it's left, and it's negative, so 1 unit down, right? Okay, so keep in mind, we have this 45 degrees. It kind of works out well that we did every other one is 90, because then the 45 degrees, one box in any direction is 45 degrees, right? The first box, one shift is 45 degrees. So if I'm doing a 45 degree shift left and I'm looking at my green graph, because that's the latest graph that I've drawn, I'm no longer paying attention to the orange graph at all because I've now changed it, right, to the green one. So when you're doing these graphs, you pretend that you're only looking at the last one you did and all the other graphs don't exist. So looking at this one, obviously I'm off the graph here. So I'll start with this one then from left to right. I'm going to shift it 45 degrees to the left, which is 1 unit to the left. That's 45 degrees, and 1 unit down. But be careful, because 1 unit down, if this is 3, is going to 2, is actually shifting down 2, right? So be careful with that. Go back to my green. My next green dot would be here at negative 180 and theta being 0, right? So I'm shifting that 45 degrees to the left, and 1 unit down is again technically going down by 2. And then my next dot would be down here, moving it 45 degrees to the left and down 2. I'm going to run out of room here, 45 degrees to the left and down because I'm moving it down 1, but 2 spaces is what I mean. And then this dot, 45 degrees to the left, and then moving it down 1 would be down 2 spaces. Moving it left 1 and down 2. Moving this left 1 and down 2. Moving this left 1 and again down 2. And moving this left 1 and down 2. So you see all my dots are kind of lining up, which is telling me I haven't accidentally put 1 in the wrong spot. And now I just have to join that together. Okay, so best I can, start wherever you'd like. It's a little hard to start here, I feel like. So maybe I'm going to start here, go down. Back up, and this one's just going to be again kind of on its way back down. But now we're off the graph, but it would just continue on its way back down. And same with this one, you can continue up. It's going to continue going up and off the graph, and it would continue on. Okay, so how did you feel about that? So first was to draw and make sure I kind of count and know where to draw my y and my theta axis. So theta can fit from negative 360 to 360. And that my y values have room for both positive and negative. So roughly, technically now I should have brought this up a little bit, right, in the middle. I thought it was going to be more positive, but I should have paid attention that it was negative, that I was going down more. Then my amplitude I can already see is 3. So I know I'm not really going any higher than 3 and negative 3, except for this shift, right? And I'm moving it 45 degrees to the left and 1 unit down. So my final graph is this red one here. Let's do one more example. If you need to pause that or take a picture of it. Okay. Let's look at this graph here, which would be cos, right? So then we have to remember, how do I draw cos again? Now, if I look here, I'm only going between, sorry, I need my pencil here, between 0 and 360 degrees. So because it's from 0 to 360 degrees, let's say I could be right along this axis here, right? But to put my, well, sure, I'll go right along that axis, sure. So let's draw a straight line right along here because I don't need anything to the left of 0, correct? And then same thing here. My amplitude is just negative. My amplitude is not changing the number, like how vertically stretched it is. It's just flipping it over the x or theta axis, right? So let's put it roughly in the middle. And then label theta and label my y-axis. So let's mark down what we have going on here so far. Now, do you remember what I was saying before? How this 3 here doesn't have a bracket between the 3 and theta. So I need to factor that out. So let's rewrite the equation. So I have y equaling negative cos bracket 3 bracket. And again, if I pulled the 3 out, 3 theta divided by 3 would be theta left, negative 180 divided by 3, right, would be 6, 12, 18. So like with another 0, so 60 degrees, double bracket, and we have no vertical displacement here. We don't have any value at the end going up or down either, not shifting up or down. So again, step 1 would be to graph y equals cos of theta. Okay, so let's start there, which is step 1, graph the parent function. I want to see if you guys remember how cos is different from sine. y equals cos of theta, and I didn't put any numbers on the graph. So let's go back there. So y, I can do the same thing. I can make 1 like every other one. So 0.5 and 1, 0.5 and 2. I don't think I'm going to need that much, right? Because I don't have a vertical stretch there. So -0.5, -1, skip 1, -2. And again, I only need positive values of theta. I just need to make sure I have room to get from 0, which is obviously right here, all the way to 360 degrees. So if I do it the same way, right, if I do by 45, right, I'd have 45 and then 90, and then 135 and 180, 225 and 270. And then 2 away from that would be 360. But what are you noticing here? I don't need to go beyond 360, right? It looks a little squished, right? And plus, if I look here, I know that this 3 is actually, remember how this one is the opposite, right? From what you're thinking. So it's a horizontal compression where I'm like dividing by 3. So it's going to be even more squished than that. So let's say I would go ahead and draw it the same way as sine. But when I draw it out and I'm already only using half of the graph along theta, along the x-axis, plus I know it's going to be 3 times as compressed as that, well, then maybe it would make more sense for me to come here and stretch this out a little more. So maybe instead of going by 45 degrees, can you think of another degree to go by here for every line? That would make sense. Where I would still get 90, I would still get 180, I would still get 270, and I would still get 360, which are the main points there. So let's go by 30, right? So let's say 30, 60, 90, right? 120, 150. Sorry, it's hard to fit. That's why I probably shouldn't write each one, right? 180. So I'll start skipping. So then another 30 would be 210, 240, right? 270, 300. Then I won't write 330, and then 360 is a little bit more stretched out, but that was just, it doesn't make sense to count by 20s or 25 because I'm not going to get 90. So that's the best I can do. So it's at least a little bit more stretched out. So let's go ahead and draw the cos of theta graph, which is starting, now remember cos is starting at 1. So let's go back to green here. So my cos graph starts at 1. Let's do my table here. So if I have theta and y equals cos of theta, and I use the same values for theta, or what would have been x, right? I use the same 0, 90, 180, 270, 360, and now I don't have to do anything on the negative, so I'm literally only graphing those 5 points. If I put in cos of 0, the value would be 1. Cos of 90 would be 0. Cos of 180, just type it in your calculator, the value of cos 180 is -1. Cos of 270 is 0, and cos of 360 is 1. So there I am starting at 0 and 1. At 90 degrees, be careful, I'm at 0. At 180 degrees, 1, 2, 3 away, right? I'm at -1, so 2 down. At 270, 1, 2, 3 away, I'm back at 0. And 1, 2, 3 away at 360, I'm back up at 1. And I'll go ahead and graph that. So that would be 1 full cycle, right? And I'll try to make that kind of as curved. Don't make that a straight line, right? Try to make that as curved as you can, coming down to the bottom and curving back up. And again, it would continue on. So if you wanted to, you could draw a little higher up than that, I think it would be, but you could draw arrows, right? Indicating, well, sorry, that would be going back down, that it would be continuing on. Let's see if I can erase just that part without it wrecking everything. Perfect. All right, so that was step 1, is to always draw your parent function. So you look, am I talking about cos or sine? You go ahead and draw that. You can draw this chart in if you want, but pretty soon you're going to have that memorized, right? So then step 2 would be, what's the next thing in line here? So let's do now if I wanted to, maybe I would flip it right now because of the negative here, right? That maybe I should flip it. So let's do that. Let's do another color. Sure, let's do orange. And let's draw the reflection, y equals negative cos of theta. So again, it's just a reflection over the x-axis, or what we're using now as theta, and then we'll worry about everything comparing it to the orange graph. So wherever it was on 1, it's now at -1, but 0 is staying the same. -1 is now +1. 0 is staying the same, easy enough, right? And 1 to -1, and then I'm just redrawing that. So now I've flipped it over the, that doesn't look too curved. Try to make it not look like a straight line. Okay, and it would continue on, and I could put arrows on there as well. All right, so now let's do my next step. Let's say here, step 3 would be to take care of this 3, which is now a horizontal compression. So let's apply the horizontal, just so I'm gonna run out of room here. So horizontal compression of 1/3. So I'm horizontally compressing it by 3, means that I'm going to divide all my, what would have been x values. So I'm going to divide theta by 3. So theta is now equal to theta divided by 3. So it's 1/3, or 1, there's a 1 in front here, 1/3 of what it used to be. So what I can do is I could draw another chart if I wanted to, if that's going to help me. Theta and y equals cos of theta. And don't forget, when you're doing a horizontal stretch or compression, and in this case, it's a horizontal compression because it's a value greater than 1. It's not a fraction, basically. Then it's actually getting compressed, and your hands are going in and closer together. And you're dividing by 3 because you do the opposite for the horizontal stretch compression. My y values are staying the same, right? So you can write down your 5 y values. But then your x values, or I should be saying theta all the time. I'm saying x just to say what would have been x. But from now on, I'll say theta, right? Your theta values are going to be divided by 3. So what was 0 is now divided by 3. But 0 divided by 3 is still 0, right? What was 90 is now divided by 3. So 90 divided by 3 is now 30. What was 180 is divided by 3. So 6, 12, 18 again is 60. 270 divided by 3 is like 27. 9, 18, 27. So 9 with a 0. Sorry, this goes to 0, just not to get them mixed up. And the 360, or 36 divided by 3, would be 12 with a 0. 120 is with 1. But don't forget that these values are now flipped, right? Because this original one for orange, right, was 0 and 1, but now we're 0 and -1. So this would now be negative and negative, and this one is positive. But basically all you're doing is going from the orange one, and I'm going to keep my values of 0, right? Where they were 0, they're going to stay 0. So for example, 90 and 0, there's a pink there, and 30 and, sorry, where am I here? Everything is going to be shifted and compressed. It's going to take me, instead of 360 degrees here to do a cycle, it's going to take me 60 degrees to do a cycle, right? Dividing by 3. So if I take, let's put in these points here, 0 and -1. And then 30 and 0, right there. And then 60 and +1. And then 90 and 0 we had. And then 120 and -1. And then you could always follow this. But really, this is what the graph is looking like, right? In order to start at -1, go up to a peak, and then come back down, and that would be my trough. This is what's happening here. Starting at -1, I'm going up to 1, that's my peak, and going back down, but it's taking, it's happening 3 times as quickly. as it normally would. So everything is being compressed by 3 and divided. All of your numbers are being divided by 3. So here I'm ending at 120, my cycle, instead of ending at 360. So you could see I could fit 3 of them in here for what used to take 1 time. So that's my dividing by 3, right? So same thing here. If I started here, my next one is at 0, then at 150, I would be at 0. And then at 60, I'm at 1 degree. At 180, I would be at 1 degree. And then same thing, back down to 0, back down to -1, back up at 0, back up at 1, back at 0, back down at -1. And then back up. So again, if you were only drawing the orange curve compressing horizontally, it would just be one of these pink ones. I'm just continuing on just because I have room, just to show you here that I have 3 cycles now happening over that 360-degree space instead of just one period, one cycle happening. But this orange cycle is being compressed and it's turning into just one of the pink, right? So now I have to do my one shift that's left. So let's do that in maybe blue will stand out on this. So step 4 would be my phase shift, which would be, if it's negative, right, looking at this one here from factoring out the 3. So my phase shift, right 60 degrees. So that's easy because 60 degrees is 2 units, 2 squares. So I just shift all of my pink ones 2 units to the right. Everyone, including the beginning and the end and the zeros and everything. So this dot is being shifted 2 units to the right. This dot is being shifted 2 units to the right. This one to the right. It's hard to follow like where you are, right? This one to the right. Be careful where I was. This one is now to the right. You have to kind of keep your place. This one is to the right. Which was the last dot I used? This one. What's the last dot? This one, and then this one, and draw your new curve. So again, it would really just be one of these, but I can continue on with the space I have. Oh, did I miss something here? The 0. And back down, and there I go. And again, I can put my arrows here indicating that, well, technically it would be going back up, right? Let me erase that. Put my arrow there indicating that it would continue on if I had more room. Okay, so homework is down below. I'll move it up if I can without erasing anything, but I'll also post it and let you know what it is. So right in there, page 383, number 1, number 5, 7, A, B, C, D, E, A to E, and then 9.